So the book starts with talking about this example of, let's say we have lumberjacks using a two-person saw, right? So the lumberjacks have one two-person saw. So yes, we have a Q is equal to F of L of K in the long run. But when we are talking about what's going on right now and what we can change right now, we really just have an F of L, right? Because they have only one of these two-person saws. So we would say our capital is fixed at 1. So since the capital is fixed in the short run, the amount of trees, right, the output, the amount of trees that we can produce, it depends entirely on this labor. And when we're looking at a situation like this in the short run, one of the important factors that we're going to need to calculate in order to make our economic decisions is this notion of marginal, right? We talked about how economics is a science on the margins, on its incremental analysis, right? So we're going to look at the marginal product here, the MP. So the marginal product, and this is specifically a marginal product of labor, right? This is the additional output of one more workers. So the marginal product is equal to a change in the total product divided by a change in the laborers. Now, what do we find happens with this marginal product, right? So because of the fact that we are simplified and we have a capital that's fixed at 1, we can throw more laborers at this problem. And yes, you know, if you go from 2 to 3 laborers, you're going to get an increase in the amount of trees that are logged per day, right? They're going to be able to take more breaks. And during those breaks, you know, they might switch one person out, right? So yes, the more laborers that you throw at the problem, the more output you're going to get. But the rate at which those extra laborers help your total product is diminishing. So we have a law here of diminishing marginal productivity. So the law of diminishing marginal productivity is a general rule that as a firm employs more labor, eventually the amount of additional output produced declines. So let's say we had some more data about this lumberjack situation, right? And let's say we hired different number of people on different days, and we took some data to figure out how many trees they were able to cut down, right? So the total product here is the number of trees, total product. And then on the x-axis, we have labor, which is the number of lumberjacks. And so we find that if we start with just one worker, which doesn't actually make much sense to me since it's a two-person saw, so how could you get any done with one worker? But we're just going to follow what the book says, right? So the book says at one worker, they're able to get 4 trees accomplished, right? I mean, I guess, you know, you don't have to have somebody on the other side of that saw. You could still saw a tree with one person and 2. I mean, we should YouTube that, right? I bet there's somebody. But then if you add a second one, right, obviously you're going to get a large jump. So you're going to go up to 10 trees. Then if you add a third worker, like I said, they're going to be able to take some breaks and stuff like that, right? But you're not going to get the same jump that you got from going from 1 to 2. You're going to go up to 12. And then if you add a fourth one, you might go up to 13. If you add a fifth one, you're probably still at 13 or 14. So this is 14, and it's going to plateau there. And so we see that our total product curve looks something like this, right? So it is a concave curve. It is increasing, but it's increasing at a decreasing rate, right? The slope of the curve, the rise over run, is much higher down here than it is over here, right? The run is much longer than the rise as we go from left to right on the curve, right? And that decrease in the rate at which this curve is increasing, that's the diminishing marginal productivity that we're seeing. And so what we can actually do, right, is we can look at the individual marginal productivity, right? So how much extra are we getting when we go from 0 laborers to 4 laborers, right? So we're going to have another graph underneath this, which is going to be our marginal product of trees. And then we're going to have, again, the number of lumberjacks down here. All right, this is going to be labor. And so we see that at 1, right, we're going to get 4 extra compared to the 0 we started with. At 2, we're going to go from 4 to 10, which means we're going to get 6 extra at 2. So the extra output from adding that second worker is 6. The marginal product for the second worker is 6. What about for that third worker, right? For that third worker, if they're going from 10 to 12, that means the marginal product of the third worker goes down to 2. The fourth worker, it's going to, again, be at 2, because it goes from 10 to 12, then 12 to 14. And then the fifth worker is going to be no gain. It's going to be 0 because of the fact that we plateau between the fourth and the fifth worker. So our marginal product gives us something like this. So as workers are added, the marginal product does increase at first, but sooner or later additional workers will have a decreasing marginal product. Why? Because our capital is fixed. We're living in the short run when we are just looking at labor, and our capital is fixed, which is limiting us. So we have some general rules that we're going to find, right? So this translates well to our general case, which looks as follows. When we have total product on the y-axis and labor on the x-axis, we get a total product curve that looks like this, kind of an S. And then we have a general case for our marginal product. Our marginal product is going to look something like this. Oh, I cannot draw as well as I would like. It should be an actual function, right? So the way I drew it initially, or the second time, it wasn't a function because it overlapped on itself. So in order for something to be a function, every x has to have an individual y value. Okay, questions on total production, marginal production, and the law of diminishing marginal returns in the context of our lumberjack example, or just in the context generally? All right.